All right, in 5.4 part 3, we are just going to put everything together that we've talked about in the last two parts. So we're going to look at A, B, C, and D shifts all within one problem. And then we're also going to throw one more thing in. Okay, what would happen if A is negative? Okay, so let's just talk through these steps and then go through some examples. So the first thing that we would want to do when graphing a sine or cosine function is sketch the midline. Okay, that will always be the horizontal line at y equals d. Okay, and remember that's the number that's being added or subtracted. Then we want to find the maximum and minimum y values by going up and down a distance of a from the midline. A tells us the amplitude. Then this is a slightly new part. Okay, everything that we've looked at so far on the inside of a trig function has been of the form b times the quantity x minus c. In other words, b has already been factored out for us. Sometimes we'll encounter things where b is not factored out for us, and we'll look at a few examples here in a second. Okay? If it's not already, we need to factor it out so that we can clearly see what b and c are. Okay, then these next three steps are what we talked about in 5.4 part 2. Okay, if we have a B or a C shift. Okay, set that entire inside part equal to 0 to give me my starting x value for a period, and then set that entire part on the inside equal to 2 pi to give me my ending x value for one period. Split that region up into fourths. Okay, and we talked about the easiest way to do that is to first find the point that's halfway in between the two endpoints, or take the average of those, and then do the same thing again twice, right? Then find the average of each endpoint with the midpoint, right? And then finally sketch the basic shape of sine or cosine. We know sine starts at the midline, cosine starts at the maximum. Now, like I just mentioned, okay, in this section we are going to look at the possibility that A would be negative. Okay, if A is negative, the graph is reflected across the x-axis. So instead of sine starting at the midline and going up and then back down, if it's reflected across the x-axis, sine would just start by going down and then up. Okay, same for cosine; it would just be reflected across the x-axis, and we'll look at examples here. So let's run through 4 of these here. Okay, so here is my first example. Okay, there's a lot going on here. All right, so first it says sketch the midline at y equals d. Okay, so to get an appropriate scale, we kind of need to think about, oh, here's my d value, here's my a value. So from 2/3, I'm going to be going up 1/3 and down 1/3. Okay, so I mean, we can make 2/3 right here. Say let's say that every 3 spaces is 1/3. Okay. Okay, so to do that, we kind of need to think about what our D and A values are. So here is 2/3. Okay, that is my midline. So I'm going to sketch in a dashed line there. Down just a bit. Okay, then I am going to label these points, which I already drew in. I know I'm going up and down 1/3. So if I go up 1/3, that'll be 3/3 or just 1. If I go down 1/3, I'll be at 1/3. Right? Then the second thing that we want to do is take the inside portion and figure out what my starting and ending x values will be for one period. Right? B is already factored out for us, so I don't need to worry about that. So I'm just going to take, for my start, 1/2 times x plus pi over 4, set that equal to 0, multiply both sides by 2, that will still be 0, subtract pi over 4, and we'll have x equals negative pi over 4. Okay, so that is my starting x value. And my ending x value, right, we want to take that inside part and set that equal to 2 pi. So multiply both sides by 2 and subtract pi over 4. So again, thinking in terms of fractions, we could say this is 16 pi over 4 minus 1 pi over 4 would be 15 pi over 4. So we want to take this region from negative pi over 4 to 15 pi over 4 and split that into fourths. Okay, now, again, if you need to use your calculator or if you need to write this part out, please do. Okay, but all we're doing is taking the average of these two numbers to find the value that's right in the middle. Average is all of our items added together divided by the number of items. So we just have two things. I'm adding these two things together and dividing by 2. So negative pi over 4 plus 15 pi over 4 would be 14 pi over 4 divided by 2 would be 14 pi over 8, which would reduce to 7 pi over 4. Then we just want to do that same thing again for here. Okay, so negative pi over 4 plus 7 pi over 4 would be 6 pi over 4. Divided by 2 would be 6 pi over 8, which would reduce to 3 pi over 4. And here, 7 pi over 4 plus 15 pi over 4 would be 22 pi over 4. Divided by 2 would be 22 pi over 8. And that would reduce to 11 pi over 4. Okay, so these are my 5 key x values. Okay, so let's see. If we say that we're going from negative pi over 4 to 3 pi over 4. So here I'm making each space pi over 4. Okay, remember we talked about trying to put the y-axis in as accurate a spot as possible. Okay, so here we do want to make sure to think about the fact that the y-axis would be closer to negative pi over 4 than it would be to 3 pi over 4 when we're making our scale. Okay, so then 7 pi over 4, 11 pi over 4, and 15 pi over 4. And finally, we want to sketch our shape. So this is sine. So I know I'm starting at the midline. So right here, I'm starting at the midline, going up to the maximum, back down to the midline, then to the minimum, back up to the midline. So let's sketch in our sine curve. Okay, so again, what I'm looking for when you're graphing these is your labels on the y-axis and the x-axis, right? That's what I'm looking for. And then obviously that you're drawing in the correct curve, right? Don't draw in the cosine curve once you have all these labels. Now there is one other thing that we want to do here. We want to give the amplitude, range, and period. Okay, so the amplitude of this graph, remember that is just the distance from the midline to the min and the max. Okay, that's always just this value here. Okay, and even if there was a negative sign here, amplitude is a distance, so amplitude will always be positive. Okay, so we say that distance here is 1/3. The range then goes from 1/3 up to 1. And finally, the period, that's just the distance from my starting point to my ending point. And remember, we said that that was just 2 pi divided by the b value. So in this case, the b value is 1/2. 2 pi divided by 1/2 is the same as 2 pi times 2 over 1. So that would be 4 pi. Right? And we can see the distance from negative pi over 4 to 15 pi over 4 is 4 pi. Okay, so after we get all of this information, we also want to give these three pieces. Okay, let's go through a couple more here. Okay, how about 2 times the cosine of pi times x minus 1 minus 3? Okay, so let's start with the midline. Okay, I know that my midline is going to be at -3, and my amplitude is going to be 2. Okay, so I'm going to be going up and down 2 from -3. Okay, so if we make each, um, or we label our y-axis like this, I think that'll work out well. So let's label the midline then. I'm going to draw in a dashed line at -3. Okay, and I know I'm going up 2 and down 2. So my max is going to be -1, my min is -5. Right? So b is already factored out for me. I don't need to worry about that. Now, I just want to take this entire inside portion and set that equal to 0 to get my starting x value. So we've got pi times x minus 1 equals 0. Divide both sides by pi, add 1 over, and we just get x equals 1. Then my ending value is going to be pi times x minus 1 equals 2 pi. Divide both sides by pi, and we'll get x minus 1 equals 2. Add the 1 over, and we get x equals 3. So this one, it looks a little bit different than ones that we've done before in that there is no pi in our x values. Okay, I'm just going from 1 to 3. Halfway in between there would be 2. Halfway in between 1 and 2 would be 1.5 or 3 halves. Halfway in between 2 and 3 would be 2.5 or 5 halves. So these are my 5 key points on the x-axis. Okay, and that's certainly possible if our b value has a pi in it. Right, that would cancel out when I'm dividing here. So I just need to label. Let's see if we're going every half. So if we're making that, so let's go out to here. We would make every 4 spaces 1/2. Okay. Now I'm sketching the cosine curve. So we know cosine starts at the maximum. In this case, we said our maximum was -1. Then we go to the midline, then to the minimum, then back up to the midline, back up to the maximum. So here would be 1 period of my cosine curve. All right, then we do still want to give the amplitude, range, and period. So the amplitude is 2, the distance from the midline to the min and the max. The range, remember that's all the y values. So I'm going from -5 up to -1 for my range. And then the period, is just the distance covered by 1 period. So that is just going to be 2 pi divided by the b value, which would just be 2. Okay. Let's go through a couple more here. And in these next two, there are a couple of different things. Okay. Notice this one will have a negative sign, so we will actually be reflecting this one. And we're going to have to factor out the b value. Okay. But let's start with labeling the y-axis. Okay. So here, my midline is going to be at -1/2. Okay. And my amplitude is 5. So looking at this, right, I only have enough space to go by 1 every time if my amplitude is 5. So if we are going here, right, -1, -2, -3, right, each space is just going to be 1. So my midline, I'm actually going to have to put right through the middle here at -1/2. Okay. Then, if I go up 5 and down 5 from the midline, okay, let's label those points here. Okay, so if I'm at -1/2 and I go up 1, 2, 3, 4, 5, I'm going to be at 4.5, right, or 9 halves. And if I go down 1, 2, 3, 4, 5, I will be at -5.5 or -11 halves. Okay, so in this case, I'm just going to label those points, okay, so we know those are my min and max. Then let's talk about factoring this b value out. Okay, if I rewrite this by factoring a 2 out of both of these terms, I can rewrite this as 2 times x plus pi over 2. Okay, in order for our process to work, we need to make sure that that b value is factored out. And remember, factoring something out just means we are dividing, right? So I'm just dividing both of these terms by 2, right? Then we're subtracting 1/2. So now I want to set this equal to 0 and equal to 2 pi. So 2, let me label that as start. So we've got 2 times x plus pi over 2 equals 0. Divide both sides by 2. And subtract the pi over 2 over. We'll get x equals -pi over 2. Then my ending value for one period, I've got 2 times x plus pi over 2 equal to 2 pi. Divide both sides by 2. Get x plus pi over 2 equals -2 pi. Oh, I'm sorry, that's not right at all. Equals positive pi. All right, 2 pi divided by 2 is pi. Then subtract 2 pi over, and we'll get x equals pi over 2. So I'm starting at -pi over 2 and ending at positive pi over 2. So halfway in between that, hopefully, is pretty obvious. That's just going to be 0. Then halfway in between -pi over 2 and 0 would be -pi over 4. And again, we can go through that process of finding the average of our endpoints, okay, or finding the midpoint, right? We're just taking our endpoints, adding them together, and dividing by 2 to get this value. Okay, so these are my key x values. Right, so let's go a distance of 4. So -pi over 2, pi over 4, 0, pi over 4, pi over 2. Okay, so now we are graphing sine, but we are graphing negative sine. Okay, so normally my sine function would start at the midline, go to the maximum, come back to the midline like this. But if I'm graphing negative sine, it is going to be reflected across my midline. Okay, so instead of starting here and going up, I'm going to start at the midline and just go down. Okay, so from the midline, I will be to here, then back to the midline, then to the maximum, then to the midline. Okay, so it's the exact same process. If we have a negative sign, the only difference is we would reflect across the midline then. So we're just going to sketch the basic shape of sine upside down, essentially. Okay? Instead of going up and then down, for a negative, we will go down and then up. Okay? Let's do one more example here with cosine. Okay, so here, again, we've got lots of fractions, okay, but nothing to be alarmed about. My midline is going to be at 1/3, and then I want to go up and down 1/2 from that. So to think about an appropriate scale, we probably want to think about having these as using the same denominator, right? So to get common denominators, I could make this 3/6 and make this 2/6. So I'm going to be at 2/6, and I'm going to go up and down 3/6 from that. Okay, so if I make each line here 1/6, I think that will make sense. Okay, so 2/6 or 1/3 would be right here. Okay, so let's put in our midline right through there. And then if I go up 3/6, I will be at 5/6, and if I go down 3/6, I will be at -1/6. Okay, so even if my midline, my d value, and my amplitude or my a value don't have the same denominator, we can still get an appropriate scale. Okay, so now we need to factor out a b value. Okay, so here, if I factor 1/4 out of these values, 1/4 times x minus, now pi over 2 divided by 1/4. Okay, so let me come off to the side here and we can think about pi over 2 divided by 1/4. Well, that would be the same as pi over 2 times 4/1, right? Dividing by a fraction is the same as multiplying by the denominator. So this would be 4 pi over 2, or 2 pi. Okay? So now we can think about setting this inside equal to 0 and 2 pi to get my starting and ending values on the x-axis. So if I've got 1/4 times x minus 2 pi equals 0, multiply both sides by 4, and add 2 pi, we'll get that we are starting at 2 pi. Then my ending value would be 1/4 times x minus 2 pi equals 2 pi. So multiplying both sides by 4, I'll get x minus 2 pi equals 8 pi. Add 2 pi over, and we'll get my ending value is 10 pi. So splitting that region up into fourths, from 2 pi to 10 pi, okay, well, halfway in between there, the average of 2 pi and 10 pi would be 6 pi. Halfway in between 2 pi and 6 pi would be 4 pi. And halfway in between 6 pi and 10 pi would be 8 pi. Okay, so here, let's label our x-axis. Okay, if we go every 4 spaces, that makes a nice scale here. Okay, and we can graph. Now, we are graphing negative cosine, okay? So we know the basic shape of cosine would normally start at the max, go to the midline, then to the min, then to the midline, then to the max. But if we are sketching the opposite of that, I'm just going to reflect across the midline. So I'm going to start here at 2 pi. At the minimum, go up to the midline, then to the maximum, then to the midline, then to the minimum. All right, so we should end up with something that Looks like that. Okay, now I forgot to do this on the last one. We'll go back and fill that in here, but we need to give the amplitude, range, and period. So my amplitude, the distance from the midline to the min and the max, is 1/2. The range is going to be -1/6 to 5/6. And finally, the period is 2 pi divided by my b value, which was 1/4. So 2 pi divided by 1/4 is a distance of 8 pi, right? From 2 pi to 10 pi is a distance of 8 pi. So let's go back and do that for the third example as well. Okay, so my amplitude here would be 5, right? The distance from the midline to the min and the max. The range is going to be -11/2 to 9/2. And finally, the period is 2 pi divided by the b value. And the b value in this case was 2. So my period is just pi. And we can see the distance from -pi/2 to pi/2 would be pi. Okay, so there's a lot going on in each of these problems. Okay, but just follow the steps that we outlined up here. All right. That is it for this video. The final question is going to pop up asking you what questions you have.